Welcome everybody, and thank you very much for joining us at Cabling Installation and Maintenance for this webinar, Leading the Way in Fault Managed Power, where the inventors of digital electricity VoltServer will introduce their next groundbreaking innovation. We are very pleased to offer this information to you, sponsored by and delivered by VoltServer. The experts you'll hear from today will be Stephen Eves, VoltServer's Chief Executive Officer, Stan Milnick, who is the Chief Technology Officer for VoltServer, along with Ken Heidzik, Executive VP for Global Sales, and Rona Davis, Executive VP for Markets and Portfolio Strategy, all from VoltServer. We're very pleased to have this alignment of experts delivering information to you today. A couple of notes about this session and your participation in it. The question window is for you to use to send questions to any of our experts today. We'll have a Q&A session to wrap up the seminar after the presentation is delivered in its entirety. Please use that question button to submit any question for any of our presenters at any time today. Also, that question button is yours if you need some tech support, if something doesn't sound or look right. We do have some people on the back end here to try to help you through that. So please use that question button to send any tech support type questions our way. Finally, we thank those of you who are frequent and regular attendees of our webinars for joining us here today. Often we are talking about a Bixby credit associated with webinars that we offer. Today's seminar, because it focuses specifically on some VoltServer technology, a Bixby credit is not available for this seminar today. So we thank you for joining us. And please know that the Bixby credit does not apply to today's webinar. Very excited to have the opportunity to introduce brand new technology from VoltServer to you today. I've done enough talking. It's time for me to get out of the way and turn it over to the first presenter of our day today, Stephen Eves, the CEO of VoltServer. Stephen, whenever you're ready.
Thank you, and thanks everybody for taking the time to join us today. We have some exciting news to talk about. My job is going to talk about the company mission at a high level and to introduce our Generation 3 product, and then pass it on to others who will go into much greater detail. So VoltServer, I call this our touchstone. As far as a mission for the company, we're promoting a new type of electricity, a new format for electricity, and at a very high level, it's a type of electricity that doesn't hurt people when they touch it, even at high voltage and high power levels. It doesn't start fires in buildings or towns like conventional electricity. And one of its unique capabilities is that it coexists seamlessly with data. So it runs in the same channel or the same cable as data lines. It doesn't need to be separated either in physical equipment or in trades approach. So often a common crew can install digital electricity in a building. So why does it matter? Why does it matter to improve the format of electricity? Well, throughout history, economical access to electricity changes the fate of nations. It might let somebody read when they can't read at night, or it might power a machine somewhere else in the world. Throughout history, that's what has helped the economic condition of civilization. What's happened very recently is devices are evolving very rapidly in both the energy that they use and the digital connectivity. So they're becoming more powerful and smarter at the same time. The problem is that AC power distribution has not evolved at the same rate. If you look outside on the street right now, the equipment that you see out there is pretty much the same way that it looked 100 years ago. It's pretty slow to install, very expensive and dangerous inherently, and it's incompatible with data. So you often have to keep separation between data channels and power channels because the people that are working on a data line aren't necessarily trained to be exposed to the energy that could be released by conventional electricity. That's not true with digital electricity. So digital electricity, or today's generic term for it, fault managed power, addresses that tension between the expansion of digitally connected devices and where electricity has evolved. So this is a historical arbitrage for all of us, not just for our company, but as an economy, improving the way electricity is distributed into the world is trillions of dollars in market value. So as far as fault managed power as an industry goes, it's evolved over about a little bit over a decade now. VoltServer was established back in 2013, and we've been selling into the market digital electricity systems ever since then. In 2023, the National Electric Code adopted a new section specifically addressing fault managed power technology. That adoption signifies really broad industry acceptance of fault managed power in North America. There's many FMP systems available today, well over 1,000 systems deployed by VoltServer in many large venues, football stadiums, conference centers, airports. As far as fault managed power in general, it's my prediction that fault managed power will take over new building infrastructure in about 20 years. So new building designs will be designed from scratch with fault managed power distribution. And after that, it will expand into the grid. The inflection point for that will happen much sooner. Although complete adoption might switch over in a couple decades, there's much to be done between then and now, and much work to be gained for everybody in the industry. So one of the things that's helping on our side is what we're announcing today is the release of our new platform, which is our generation platform that we also call Tetra. That platform is going to offer much more power and much more capability that we had in our Generation 2 products. So the power capabilities has been increased to about 250% of the industry standard. We're offering more control, more communications between the devices in the power network, and it's also a simple platform, so easy to install for many different trades groups. So at this point, to go into the greater details of the technology, I'm going to introduce Stan Milnick, our Chief Technology Officer.
Hi there. My name is Stanley Milnick. I'm the Chief Technology Officer at VoltServer. I'm really excited to be here today to talk about the technology. Steve and I have been working together for a long time on this technology, and it's exciting to get to this milestone that we're at today, announcing and discussing our Tetra platform. So our Tetra Class 4 power platform. The first comment I want to make is this is really a platform, not just a product. We have two products, a transmitter and a receiver, that are launching today. But this is really intended to be a platform and a suite of products that we will grow over time, and I'll talk about that in a little bit. This is our Generation 3 product. We've taken everything that we've learned over the last decade about deploying fault managed power digital electricity systems, and we've made it better. As Steve was saying, devices and energy usage is going up, so more power is needed. So we've driven the power per channel up 2.5 times where the kind of industry standard was before, and that enables customers to do more and exciting things with the technology. We've improved our software, and really that comes down to the inline communications, which I'll talk about in a second. We've also improved our just the general usability of the product. Simple things like where the connectors are placed, what type of connectors are used, how it mounts. All of these things were considered in the design of this platform to make it incredibly easy and simple to install and for customers to use. This is, increases the functionality and enables more applications, which will be talked about later. The other real big feature that's part of this Generation 3 product is transmitter to receiver communications, or what we call inline communications. This enables greater telemetry data to come back from the receiver and control data to go from the transmitter to the receiver. And this communication is happening over same two wires that the power is being transmitted over. So there's no additional wires or no other connection that's needed to get this telemetry and this control data back and forth between the transmitter and the transmitter and the receiver. So today we're launching, from a product perspective, our Tetra 4 transmitter, which you see here on the screen, and our Tetra high voltage DC receiver. and we intend to come out with a suite of products. And one of the ways that we're able to do that is because we've architected the system. We spent a lot of time and energy on the engineering side, kind of separating the safety portion and what I call the application layer of the product design. So the safety core, it will be consistent across the product platform, the Tetra platform, and as we innovate and come out with more products around that technology. This platform is a Class 4 platform. This product has been through the UL 1400 process with UL, so it is fully ready to be installed under Article 726 of the 2023 National Electric Code. And one thing I wanted to bring up was that these systems are required to be certified as a system, both a transmitter, a receiver, and a cable. And one unique feature of the Tetra platform is it's been qualified to be used with multiple cable vendors, along with multiple different constructions, whether that be the gauge of wire, the pair count, or the environment that the cable can be installed in. And that's a unique feature of this platform from a Class 4 perspective, to give a lot of flexibility to the market to be able to use the product in the application and environment that it is needed in. I'll talk a little bit specifics on the product at a pretty high level, and then I'll talk a little bit about what we're planning to come out with. So our Tetra 4 transmitter, it's 1.5 kilowatts per channel of fault managed power. It's 4 channels for 6 kilowatts total in a 1 RU package. It has an AC input. We can deliver power up to 6,000 feet. Now that power delivered is dependent on the cable gauge that is used, but one very cool thing about this platform is we've increased our ability to use thicker cables, so we can deliver more power, more distance than our previous platform. On the receiver side, we have a high voltage DC 4 kilowatt receiver, DIN format receiver that we are launching with this product today. And that enables the ability to power other power supplies that can then in turn power the end load. Where we're planning to go here is to our next transmitter that will be coming out will be a 16 channel transmitter, so more power and even more power per channel and more input types. And then on the receiver side, we're going to be coming out with a suite of products that will be available for multiple environment, whether it's indoor, outdoor, different power levels and different voltages, such as 56 volts, 24 volts, AC, etc. One of the really great things about fault managed power, about this platform and about our products, is that it enables significant more management, control, and monitoring of the electricity and where it's used, how it's used. I'm going to tell this really simple story that happened to me recently to try to illustrate a point. About 2 weeks ago, I went up into my attic and I opened the door and the light was on. I hadn't been in my attic in probably 6 months. So I had installed this really great energy efficient LED, and then I left it running for 6 months with nobody using that light. And the reason that happened is because I couldn't monitor it, I couldn't control it, I couldn't manage that light bulb. That's really, really simple example, but it's the point of this slide, is to say that when you have the ability to monitor and control and manage your infrastructure, your electrical infrastructure, you can not only save energy, but you can enhance what you can do with that energy. So this platform and our existing platforms, but even more so with this platform, allows you to know where your energy is going. It's all monitored. It all can be remotely accessed, and it has the ability to control that energy, to turn things on and off. And that inline communications that is part of the Tetra platform allows even greater control and greater monitoring of the endpoints of the receivers, to monitor for faults, to look at power usage, to look at the quality of the power network, and do a lot of really great things. It's kind of just a footnote on the slide, but it's important to note that we've also enhanced our security as part of this software package release as well. One just really simple example that can be done when you have this capability is the ability to shed loads when you're under battery backup. So if the transmitters are powered by a UPS, right, and the power goes out, now you have a limited amount of battery energy available, you can intelligently turn loads on and off depending on criticality and how you want to use the energy that's in that battery. And that's all done in software. So if one day something changes, you need to change it, it can all be done in software to create that profile that would occur if the system went on battery backup. That's just one simple example. I'm really excited to see what the industry is going to do and what will be done with the inline communications protocol and some of the really cool things that I think will come out of that. And the last thing I'll say is that, safety and quality really always has been and is our priority. We have a dedicated engineering staff. All we do is fault manage power. We've been doing this for 10 years. We've put a lot of time and energy in understanding things at a very, very low level, all the way up to the application level to make this product and this platform and this technology as useful as possible. And as safe and highest quality as possible. We have all of our labs are really optimized for safety testing and quality testing. When we go through a design process, and this is what this product went through, we start with safety and quality right at the beginning. We don't try to just bolt it on at the end. It is something that is core to the DNA of how we engineer products. We have an extensive engineering test and validation program that all of our product releases go through, and all of our product is tested at the end of line for product quality and safety, so we can ensure that that product is going to do what it says it's going to do, and will be safe. Like I said, I'm really excited about what this technology is going to do and where it can go, and this platform really is a big enabler of that. With that, I will pass it off to Ken Heitzig, our Executive Vice President of Global Sales.
Thank you, Stan. Appreciate that great overview for the team here, and thank you to everyone for being on this call. So what I want to talk about is, we've talked about the technology, we've talked about fault managed power. The team that I work with and our team, that's our global team, is really responsible for how is the technology, the great and wonderful thing we've invented, fault managed power, utilized. What are the use cases, and what does the Tetra platform bring to these new markets that we're going into, and where we see the utilization of this platform really taking off. So, one of the things I really want to focus in on is, while fault managed power may be new to some folks on this call, it may be new to you, it's not new to the industry. And VoltServer has been deploying, not just been around, but been deploying solutions and systems into critical network infrastructure over the last 10 years. And as Steve alluded to and mentioned, that we've got over 1,000 installations, and these are with Fortune 500 companies, tier 1 players in the market today. Many of you have probably been through airports, have been in ports or transit systems in North America and over into Europe, where your phone may have been running on a network, or probably was running on a network that VoltServer is powering. So as Steve mentioned, when you turn on the TV on Sunday to watch your favorite team, more than likely we're in that venue powering that network. We're almost like BASF. We're kind of the quiet ones in the background. So the applications where we're utilized, I mentioned critical network infrastructures, going on 10 years now. That includes everything from stadiums to hospital type environments, major transportation hubs, be it metro rail systems, airports, etc., to signature resort properties, where the customer experience, having that connectivity, being able to order my room service on my iPad is critical to those venue owners and operators in making sure those customers return and come back. So we've got that 10 years of experience and I'll say frankly lessons learned in how to support those tier 1 critical networks and understanding that quality is job one. What we're really excited about with Tetra from the sales and solutions engineering team is that it really takes those lessons learned over the last 10 years and incorporates it into the engineering. I use the analogy of if you pop the hood on a car today versus 20 or 30 years ago, you don't see all the piece parts that you saw 20 or 30 years ago. You pop the hood on a car and there's a plastic cover and it just looks like a module. Or you look at an EV and you see that. What we've really done, or what Stan's team has done, is taken those lessons learned and incorporated into the system. So from a user interface standpoint, the system is inherently simple. We've engineered the old KISS theory of keep it simple. into the customer experience for that and the customer utilization for that. So when we look at the markets that we're expanding into, we really see, and smart buildings is such a broad term. I'll call it buildings with intelligence, and that could mean a host of applications, which I'll get into here in a moment. But additionally, when we look at manufacturing, Industry 4.0 applications, the need for devices further into that facility is absolutely critical to support where industry is going. And when we look at, another aspect that the platform is targeted toward and going to be a great fit for is really around the data center and the AI environment. If anybody on this call hasn't heard AI at least 5 times this week, well, then maybe they're living in the mountains in Montana in a cabin. But I think we've all heard plenty about AI, and who knows where it's going to go. I certainly don't, but the world's going to be different in 2, 3, 4, 5, 10 years from now. And we fundamentally believe that this platform is well suited to supporting that growth and that dynamic change. So when we talk about the applications where we really have targeted Tetra toward, it's everything from security and monitoring, and that could mean anything from cameras to personnel sensors to LiDAR to thermal imaging. What we're seeing across all these applications, when we look at industry and we look at data center, when we look at even EV charging, what we're seeing is the need to get high bandwidth data closer to the edge, closer to those end devices. When you look at an industrial factory, I'll use an example of, if you've got a large factory and you've got machines that are operating in that environment, well, your OT department, your operational technology department, is out there trying to deploy, those fiber closer to those devices. Well, that device that I've got to put, that's going to be at the end point of that fiber, could be an industrial switch, it could be an IT switch, it could be any manner of IoT type device. That device needs power. And what we're able to do is minimize the impact to that facility by deploying that power from the same location and in the same pathway as that data channel. That's a fundamental change, and that's what's allowed us over the last 10 years to deploy in the installations we're deploying. We make it easy and cost effective for our partners and for our customers to deploy in those environments. So moving on, I call this the why do I care slide, right? If you're new to VoltServer, you're new to Fault Managed Power, what are the benefits that Tetra is going to bring to me, and how is this going to help me with the 25 problems I've got to solve this week? So when we're talking to facility managers or deployment teams, with Tetra, Stan's team put a ton of effort into really taking those lessons learned, optimizing the system to minimize connection points, make those connection points easy to access. Simple things like pre-terminated cables. It sounds silly, but it saves time and effort and energy for the deployment teams. And when we talk about the intelligence, and Stan alluded to this quite a bit, I joke that we're the AI of power. I think I just throw AI in there so we can get more attention. But when you think about it, it really is bringing intelligence to what traditionally was an unintelligent system. You go deploy your AC throughout your venue or throughout your facility, you don't think about it. With our system, we bring that level of visibility, that level of monitoring, and fundamentally that level of control to that infrastructure that wasn't there traditionally. Legacy technologies or legacy methodologies for deploying power, just simply put, didn't have that. This is a game changer. We're really bringing intelligence to that application layer. Now, when we talk about sustainability or ESG, and I know Rona's going to go into this a little bit, but one of the things, just to keep it simple, we eliminate the need for conduit in many instances. Now, the facility may require conduit from a protection standpoint, depending upon the type of facility, but we minimize the need for extra conduit for that power layer by being able to be in the same pathway as that data channel. So the need for additional mined materials, for that aluminum or that metal or that plastic, is not needed with our system. So we really have less infrastructure required. And this has been core to our deployments going back 10 years. the ability to move, add, change, you simply put cannot provide the same level of flexibility for power infrastructure with legacy systems that you can with VoltServer's fault managed power architecture. And what I mean by that is if you think about a customer, we have several customers where their infrastructure is dynamic. They're changing to meet the needs of their customers. They may be needing to relocate switches or picking machines or robots within the facility, manufacturing robots within the facility. The ability to move power along with the need to move that data and where that device is located and what it's doing, the flexibility to do that is unparalleled with any legacy system that's in there. And when we start to look at some of the efforts around decarbonization, some of the standards and mandates that are out in some of the states, I live in Washington State, it's a big issue for builders, for customers, for landlords that have tenants in a facility and they have to eliminate natural gas. So there's this huge push in many of these venues for electrification. Well, if you're in an existing facility, the electricity or the infrastructure to power those new loads may not be there. And more often than not, it isn't there. So the ability to overlay power in a less intrusive manner to your tenants, and that tenant could be a corporation within a warehouse or what have you, but the ability to overlay power in those types of environments, overlay an IT network or overlay, a cellular DAS network within an existing venue is a huge benefit for the people and our partners that we work with. So the flexibility of fault managed power alone is huge in that aspect. And we have systems, like I said, we've been deploying for 10 years. We're going to continue deploying those systems. Our Gen 2 platform is an excellent platform. It's widely adopted within our existing markets. Tetra is a migration of the technology to address some of these new markets beyond our historical and legacy customer base. And I can sit here and tell you how great VoltServer is and how wonderful we are. Talk to our customers. They're the ones that speak the most. They're going to carry the most weight. And the feedback from our customer, and we do voice of customer, we get, hey, what can we do better? We ask our customers that all the time. And along those lines, thus far, because of the team that was built over the last 10 years, we've got an incredible team here that believes in supporting our customers. We view our customers as, from a collaborative standpoint, we don't view, I hate using the term customers, I call the folks we work with partners, because we really do view it as a partnership. And I've been here for over 8 years now, and I've got an engineering background, and before I moved into sales. And one of the things I love about working at VoltServer is if we're not the right solution, we'll tell you. Because guess what? When we are the right solution for you, you're going to come back to us and say, hey, I trust those folks. They're straight shooters. That's the approach we take with our partners and with our customers. And along those lines, we've got a team of dedicated sales professionals and solutions engineers that provide these solutions to you. Our team are experts at fault managed power. We leverage that team. We use the heck out of our team and use the heck out of that skill set. And we really do have those, I call them the scars, lessons learned, right? I don't know about everybody else on this call, but I always remember I don't remember the attaboys, I remember the aw shucks. And you learn from those and incorporate that into how you behave going forward. So we've got those scars, we've lived them, we've experienced them. So, one of the aspects that we have here that is a huge benefit to VoltServer is our solutions engineering team. And we leverage the heck out of that team. The team has over 110 years of combined experience, not just deploying fault managed power, but running, operating, maintaining tier 1 networks, whether it's an IT network, whether it's a cellular network. Our team has experience and has lived that. So we understand what our partners go through on a daily basis. And along the lines of not having to be fault managed power experts, going back to that, fault managed power may be new to you, So one of the things we do and as a value add for our partners is you don't have to be the fault managed power expert. We do that for you. We design the VoltServer systems for you. We engineer them for you. And then following on to that, we train you. We train you both on installation, we train you on operational support, because it's not just, hey, we sold you the equipment, have a nice day. It's making sure that you understand that equipment, you know how to operate it, and when something goes bump in the night at 2 a.m, you know there's a live person on the other end of that phone call, and you're like, hey, I got a problem, can you help me? So we have a 24/7 tech support line that is fully staffed, and along those lines, we have a full suite of installation and operational support documentation. And along those lines, in getting you to be fault managed power experts, we're in the process as we expand into these new markets of our online certification and training. That's going to be launching in Q4 of this year. I realize we're in Q4, but it'll be launching in the November, December timeframe. And that really is going to allow you to go in and become trained up on all the details of the VoltServer systems. And that training and support is the culmination of 10 years of experience, of 10 years of understanding, hey, what are the gotchas you might not be aware of? What are the FAQs? You know, where do you use it? Where do we provide the most value for our partners? So with that said, I'm sure we'll be talking on some of the Q&A a little bit more. You'll hear from me, but I'm going to kick it over to Rona Davis, who is our EVP of Products and Markets. So Rona, I'm going to go ahead and mute and let you take the wheel.
All right, thank you so much, Ken, and thank you to our customers and our partners who have joined us today for this exciting announcement. It is a great day to talk about fault managed power. And as Steve had said at the beginning of our talk, we've reached this inflection point with fault managed power, and Tetra is truly meeting the moment. I want to spend some time before we close today and talk about that inflection point and specifically what's driving the market towards fault managed power. So VoltServer, we deliver our version of fault managed power, digital electricity, through 3 primary means or methods. We build products that are VoltServer branded and we sell them into the market. We also embed our technology in other manufacturers' products and solutions. Now, this is that path to scaling fault managed power. We're laying the groundwork now so that fault managed power can be a native power type that's embedded in many of the devices, the appliances, and systems that you use every day. And finally, we partner with stakeholders that improve our technology or we improve theirs, and partners that can help us get deeper or farther into markets and customer applications than we could do on our own. So fault managed power is really an enabling technology. So you could liken us to an Intel Inside. We like to call it powered by digital electricity. And we're really eager to expand that set of embedded and technology partners so that we can tackle the big challenges that are ahead of us. Now, at VoltServer, we look at challenges as opportunities to improve situations and opportunities to solve problems. And we certainly are facing some real challenges that are driving that need for safer, smarter, simpler power solutions. Power demands are skyrocketing globally. And while we're driving that efficiency of individual devices, we can't seem to do that fast enough to keep up with the general growth in the number of power devices and, of course, that demand for high compute. Now, this growth in power demands is causing real issues for electrical product supply chains. There's lead times that exceed a year and even up to 2 years right now on electrical equipment. We also have an aging electrical workforce, and we have priorities around reducing carbon at the business and at that governmental or regulatory level. Ultimately, what this means is that those capacity and labor constraints are stifling our growth, they're slowing our progress. Now, if we want to talk specifically about the power infrastructure challenges that we're facing, first, we'll start with buildings. They use a significant amount of energy. They are too energy intensive to meet our net zero goals. So we've got to reduce the amount of power that we're using in buildings. We've got to get smarter there. Secondly, a big initiative, and Ken hit on this in many jurisdictions, is to limit or eliminate natural gas in buildings. These decarbonization efforts are shifting the power demand previously supplied by that natural gas onto the electrical grid. Another thing that's happening is we have about 28 million level 2 EV chargers that are going to be added in the US by the early 2030s. And so some of these are going to be supported by renewables like solar and wind, but much of their power is going to come from our electricity grid. And the final point, look, data is also a culprit. ICT is responsible for 21% of global electricity consumption. And when I read this, I was surprised by that, because I think buildings, I think transportation, but all of that requires data. Everything requires data. So the amount of power to process data, it actually makes sense that it's 21%. So those of us that are in the ICT industry or ICT adjacent industries, we have a real stake in electrification. Now, digital electricity is going to help to solve some of these electrification challenges. So we all know by now that fault managed power is safe power, right? And I have a saying, safe power changes everything. It's kind of my mantra. I believe in it 100%. And our safe power is also smart power, and it's a DC power. Smarter power means you'll be able to control every single circuit. You can manage your power platform to ensure that you're getting the most efficient utilization of every watt of power that's available. You don't have to overbuild your system, and you don't have to suffer from stranded capacity. And then DC powered buildings, they show significant energy efficiency gains. There was a pretty exhaustive study done by the Department of Energy, the Lawrence Berkeley National Lab, on DC powered buildings. The link is down at the bottom, so it will be in the PDF handout that you get from this event. I implore you to take a look at it. There really is a compelling case for using DC power further and deeper inside of the building. Now let's layer onto that a safe format for DC power that is also inherently intelligent. So these are going to help us to kind of meet the moment around these power infrastructure challenges. And the fact that we are safe, and that makes it easier to install our product. There's far less complexity. This is going to help us with our labor issues, which is a very real situation. So if you're training to be an electrician right now, congratulations. It is a great time to be you, because electrical worker positions are growing at double the rate of all other occupations. We're currently nearly 50,000 electricians short from being able to complete the work that's in front of us. And it takes years to properly train an electrical worker to work on traditional electrical systems. They're dangerous, right? Fault managed power still requires professional qualified electrical workers, but the upskilling time is drastically reduced. And fault managed power opens up the electrical industry to more potential candidates, because let's face it, electricity is dangerous work, right? And so if we want to bring more people into that occupation, making it a safer workplace, a safer opportunity for them, should generate more interest in the field. Fault managed power is the bulletproof vest for electrical workers. Now, unfortunately, I have a little bad news for you. That lack of skilled workers really does hurt business, and it hurts our economy. Labor inefficiencies are plaguing our projects. They're causing delays and overages and lost profits. Now, there's a ton of work that's happening all around the construction space to increase prefab, plug-and-play type solutions that reduce the amount of skilled labor hours that are required, especially that kind of on-site labor. Now, fault managed power is another labor-saving arrow that you can keep in your quiver. It typically reduces labor hours on a project by half, so literally 50% less labor hours. Now, that means if you're a contractor that you can complete more projects, or you can get more done with a smaller staff. And if you're a building operator or building owner, it means that you can occupy and utilize that real estate asset sooner. Now, ultimately, we're not going to escape this one. We need labor. So we need to get creative in bringing more individuals into the field. And this is a really important point here. We have to be creative with the solutions we design, because if we don't design in the labor saving solutions, you won't get labor savings. And in fact, you could suffer the consequences of this very real labor shortage that is expected to continue for the next decade. So there are some other drivers for fault managed power. There are incentives and programs, some regulatory, some voluntary, some are carrots and some are sticks. Now, typically, you need both to get people and businesses moving in the right direction, but let's start with some of the carrots, tax credits. So under the Inflation Reduction Act, there are tax credits available for using DC microgrid, and fault managed power, the power transmitters qualify as a DC microgrid. And then there's also tax credits for improving energy efficiency by square footage. These are very lucrative tax credits. You do not want to ignore these. And nonprofit and tax-exempt institutions also qualify for those tax credits. Additionally, there's programs for schools like the Renew America Schools program and E-rate. E-rate, it comes up every year. Many of you who are on the call are probably very familiar with the E-rate process. Fiber to the classroom, powered by digital electricity, is an amazing solution to get the most advanced learning technologies deployed into our children's classrooms. Okay, so let's talk about some sticks. So that's some carrots. Let's talk about some sticks. There are decarbonization initiatives in most states today, and many have specific regulatory requirements to reduce carbon by a certain date. If reductions aren't made, fines are imposed. So New York has the Climate Mobilization Act, California has Cal Green. Ken talked about, he's from Washington State, they also have regulations that's happening there. I definitely would tell you to please keep yourself up to date on your state and the states that you do work in. Some of these regulations really do have some pretty serious implications if they're not met. Now, finally, we're going to talk about some more carrots. These are those voluntary sustainability building programs like LEED, GBI, WELL, and the Living Building Challenge. They all have points and incentives for moving to smart power distribution, and many of them offer innovation type credits for solutions that address sustainability, but they're outside of their primary points categories. And so for customers or building operators, having that sustainability certification for their property improves the value of the property, but it also helps them to reach their individual decarbonization goals. Now, these buildings, they're the flagships, right? They're the beacons for a more sustainable, healthier future. If your clients are pursuing one of these sustainable building certifications, make sure they know about fault managed power. And I'm going to correct myself there. Make sure they know about Tetra from VoltServer. Now, if you're an architect, an engineer, a contractor, a building inspector, all the way to the product user, Tetra's value spans the entire ecosystem. More power, more control, more simplicity. Who's ready to power some stuff? Patrick, if you're ready, I think we have some time to answer some questions from the audience.
Terrific, Rona. Thank you. And thanks to everybody from VoltServer who provided information today. Thanks to the members of our audience who have joined in so far. And Rona, yes, we have time for questions, and we have a number of questions lined up. So I'm going to get right to it. I'd like to start by asking a question. When will the products discussed today be available for order, and where can these products be purchased?
Yeah, Patrick, I'll take that one. This is Ken. So
thank you.
These products are the Tetra 4 platform that Stan alluded to, and the associated receiver are available for specific customers that we've allocated many of them, but those are going to be available in Q4 with in a limited availability fashion and general availability at the end of Q1.
Thank you. Thanks very much. I'd like to move to a couple of questions that came in while Stan Milnick was presenting. So Stan, I believe these are going to be aimed at you. I might have some others for you as well, but I would like to start off by asking asking about a UL listing, and I believe that's something that you may have mentioned at some point in your presentation, but it is a question that did come in from an audience member. Are we talking? Is it UL listed?
Yeah. Mm-hmm. Is it UL listed is the question. The Tetra 4 and the receiver is listed. It is listed to 1400-1.
Thank you. Another question for you, Stan. For the Tetra receiver, you mentioned HVDC. What voltage levels are you talking about when you make that reference?
Typically between 320 and 350 volts DC.
Perfect. Thank you. I'd like to ask you one other question that came in during the seminar itself. It was a little bit after your portion of the presentation, Stan, but I think you may be the person with the most direct answer. An attendee asks if you would please talk a bit more about the new transmitter to receiver communications, and is it operationally different than the PTX 500 DC VoltServer technology or similar generation products?
Okay, I can do that. So compared to, in terms of practically getting power from point A to B, power is still delivered just like our prior generation product. There's just more of it available. The communication aspects of it is bringing back data from the receiver that is not presently brought back on the prior generation. Things like faults on the output of the receiver or the temperature of the receiver and things like that. Practically speaking, both those products deliver power. The new Tetra has more data associated with it from the end receiver.
Stan, thank you. Thank you for those answers. Thanks for all the information you presented today. We may be coming back to you depending on how Q&A goes, but I want to extend my thanks for all the information you provided today. Ken, we've got a number of questions lined up for you. Do we have you back, and can I start sending them your way?
Absolutely. Fire away.
Thank you. Thank you. During the course of your presentation, somebody asked, is this technology the same as power over Ethernet or DC power? And then alongside with that, the question is, what is the energy source for the electricity? So kind of a two-part question there. Are we really talking about the same technology as PoE, and then what's the energy source?
So yeah, let me start with PoE. So VoltServer is not PoE. Power over Ethernet is limited to sub 100 watts, with some of the UPoE, UPoE++, some of the IEEE standards that are coming out. So Ethernet is a utilization of power from a distribution hub, whether, a PoE switch, it could be an industrial switch, or it could be a rack mount IT-based switch that's a PoE switch, where it then delivers power and data from that device. And when I say power, I mean low levels of power, sub 100 watts, out to those IoT devices or those endpoints within that, coming off of that PoE switch. VoltServer works with PoE all the time, and the way we do that is we power the PoE switch. So VoltServer is a means of powering the switch. So if you think about it from a legacy power aspect, think of the PoE switch as the breaker panel in an AC format, and we're the feeder circuit for that breaker panel. So PoE power powers those very low power devices in a zone, or think of it like a hub and spoke topology, where we're bringing power to that hub or to that switch. So that's where VoltServer fits in with PoE. We marry our system up with PoE and with Class 2 distribution all the time, and we work with partners to do that. When we look at where do we source power from, we don't generate power. We're not a generator, right? We take power from a location where power is available. It could be AC power, or it could be power coming off of a DC plant, and we feed that into our transmitter chassis. the Tetra 4 is a transmitter chassis for us. At the transmitter chassis, we generate digital electricity or fault managed power and distribute that out to our receivers spread throughout the installation. So power into our device, with Tetra 4, it is an AC input. So that is a 208, 240 input to the Tetra. We take the AC power, we convert it into digital electricity or fault managed power, and distribute that out to our receivers throughout the venue.
Thank you, Ken. Another sort of dual question for you. Asks if you can give examples of VoltServer technology being deployed in either or healthcare environments, aviation markets. Can you talk about any deployments in either or both of those market segments?
Sure. So for both of those, and we are under NDAs and under contractual requirements where I can't go name names. I can certainly provide references, on a separate thread and get you in touch with folks that are using it in those environments. But within healthcare, it's typically hospitals. It's typically large facilities, could be a campus type environment where we're powering the networks within those facilities. Within healthcare, there's obviously numerous devices that are connecting into the IT network, and powering that IT network or that communications network is where we fit in that type of application. When we look at aviation, I'm assuming that's referencing the airport reference I made earlier in the slides. So we're deployed just in North America alone, we're deployed in over 32 airports. And if you're walking through the airport on your phone, looking up X or Instagram or what have you, odds are your phone is communicating with the network that is being powered by VoltServer.
Thank you. Another question asks if VoltServer is going to EOL end of life its second generation platform and replace it with Tetra, the third generation platform.
Absolutely not. Absolutely not. Our Gen 2 platform has been a workhorse for us. Our partners love it. We love it. It's a quality product. And frankly, we are contractually required with some of the contracts we have in place to support that product for well over 5 years from end of life notice. So there are no intentions whatsoever to end of life that product. We view Tetra and the Tetra platform, Tetra 4 and the Tetra platform as a means of expanding into new markets that don't necessarily have the same needs and the same subsets that our traditional communication markets have had. So there is a ton of utilization. We're in active deployments now, utilizing our Gen 2 platform. We will continue those deployments, and it is a great fit for our legacy applications, for IT infrastructure applications, and contractually we wouldn't get rid of it. We can't get rid of it. And frankly, from a market standpoint, it serves a purpose very well and is a great product. So the answer to that is unequivocally, there are no plans to EOL that product line whatsoever.
Thank you. Thanks very much for that. Another question asks if the ability to remotely control the system bring about any security issues that users should be aware of.
Sure, that's a great question, and there's a very simple answer to it. We do not communicate to our devices outside of the transmitter. That is installed within the customer premise. The only way communication is enabled to our device is through the customer's network at their direction. So they control access to the device. So the customer is actually doing that. We do not have a tunnel to the outside world from our system. And frankly, we don't want to do that because, as I mentioned earlier, much of our experience is through powering critical networks. So those security protocols, those requirements were built into our system to not tunnel to the outside world. So Stan, I don't know if you have anything to add to that, but that's how I would, that's our view on that.
That pretty much answers it.
Thank you.
All
right. Ken, part of the discussion, here and there throughout the discussion, the 2023 edition of the National Electrical Code has been mentioned, and the importance of that for market acceptance. A question for you is asking if you can comment on what is happening outside of the United States in terms of codes, electrical codes or other codes, catching up really to include fault managed power systems.
Sure. So the codification of fault managed power under UL 1400 in the 2023 code that Stan alluded to, I believe Stan Article 726, that is a US-based code and standard. There are other countries that are in the process of adopting that. Now, I want to be very, very clear that there are other listings that VoltServer has that have allowed us over the last 8 years to address the international markets. We are certified and listed to those codes and standards. So we have deployments throughout Europe and the Middle East. We are in active discussions in other parts of the world. And we have, with our existing systems, the ability to go address those markets under the code infrastructure that's already there. So I want to be very clear when we're very excited about the codification of UL 1400 and the specific call out in NEC. VoltServer has been deploying, as I mentioned, countless times for 10 years, and we are deployed under the existing standards of the National Electric Code, whereby our system is classified as a limited power source. So we've been doing fault managed power for 10 years, and we've been doing it, meeting the code for 10 years. So what UL 1400 and the adoption in the 2023 code does is it opens up that market for others, because we have the IP on how to do that historically. So it opens up the market for competition. And from my perspective, I welcome competition because I think it makes it hones you. Iron sharpens iron. So I think with competition in there, we're going to see, broader adoption. There's more folks coming into the industry, and we welcome that.
Ken, thank you very much. Thanks for all of that. That question and answer is a nice springboard for me to get to a question intended for Rona, and I would like to turn my attention to Rona now. We are leaving some questions sort of on the table, so to speak, today. There's several more questions, and I'm looking at the clock. I know we're only going to have so much time to answer. Ken, I thank you very much for all the information you delivered. Before I get to my set of questions for Rona, I do want to let our audience know that every question that has been submitted today is being captured. When we sign off, if your question has not been answered here on this session, please know that it's not gone forever. We have captured these questions. We are capturing these questions, and it's possible that you'll be hearing some follow-up specific to your question at some point, offline. But do want to let everybody know that we appreciate your attendance, your questions. We're getting to those that we can in the time that we have. But we know that there will be some sort of left on the table, so to speak. I've talked too much already. It's time for us to hear again from Rona on the topic of the 2023 NEC. Rona, a question for you: what if a state that I live in, the state that I live in, has not yet adopted that 2023 NEC or Class 4 yet?
Okay. Well, there's a couple ways that you can handle it. First, there are sections within the National Electrical Code 90.3D and 110.3A through D that have allowances for solutions that are included in future code versions. So the code is progressive in nature. It gets more safe over time. So something from a future code book is generally accepted, but it could mean that you have an extra step, right, within your design and build process. You're going to have that communication with your building jurisdiction. Now, the other option is to use our LPS solution, which can and has been installed in every major jurisdiction within the United States, and we certainly, as Ken had stated, intend to continue to support both LPS and Class 4 solutions.
Thank you, Rona. Another question, I'm going to ask this because not certain if it has been answered within other contexts, but a question from an audience member asks if the Tetra system requires 120 volt AC.
So, Stan, do you want to answer this, because it's sort of a progressive question? There's a Tetra 4, and then there's the platform.
the Tetra 4 specifically is 208, 240 for the full power rating. You can use it with 120 at a reduced power level, and future products in the platform will go to higher input voltages such as 277, etc.
Thanks, Dan.
Thank you. Thanks very much for that. And another question about fault managed power and PoE. I know that Ken touched upon it earlier. Another sort of adjacent question asks if we can get an explanation of how fault managed power either works with, or works alongside, or works complementary to power over Ethernet.
Yeah, I'll take that one. So, look, fault managed power is really an enabler for PoE at the edge of our network. So PoE is a class 2 solution up to that 100 watts. It is a DC power technology, so it's similar that way, but it's operating at a much lower voltage. So the way that we really see that relationship between fault managed power and PoE is that we would be the supply power, or the power to the PoE switch, and then that PoE switch is going to supply power to devices that require less than 100 watts. And we know that that is increasing, right? The number of devices that utilize PoE power is increasing. So think about using fault managed power to power the whole PoE switch, and then that PoE switch powering devices that are sub 100 watts.
Thank you. I've got one eye on the clock, and I know that we are just past an hour. I have one final question, whether that's for Rona or any other member of our panel today. Another technical question asking how the receivers integrate with or integrate into the devices that are powered by this fault managed power system. So how do the receivers integrate with or integrate into the powered devices?
Yeah, so I love this because it's really getting to that embedded that I talked about, that it's one of our go-to-markets. It's how we bring products to market is by embedding. And we actually have cards that have the digital electricity on board that can be embedded directly into devices. And of course, we know that many devices already use DC power, right? So there is advantages to just go ahead and going with the native power for the device, or only having to down convert, because of course we're a high voltage DC format, right? We're operating in that 320 to 350 volts DC. So there may be down converting, but at least we're not having to invert that to AC again, to then just convert it again to DC, which is what your equipment wants anyway. So love that question. And if there are any of you out there that are interested in embedding VoltServer into your products, give us a call. This is what we want to do.
Thank you. Thanks very much. Appreciate everything. You know, if we have Ken, I know we're a little bit past the hour. I'm going to be selfish and ask those who can stay on, wish to stay on. Ken, you answered a bunch of questions for us. Like I said, there are several more. I'll ask you one to wrap up because I think it speaks to many in our audience today. What makes a project a good candidate for fault managed power rather than traditional AC power?
I have the term I've coined over the years, and my joke is, when people say who is your competition, my answer is apathy and a plug in the wall. And what I mean by that is, if the device that's being powered, if you don't care about it, if it's a fan you're plugging in or what have you, if it's not critical to you, if it's not important to you, and there's a plug sitting there, you're probably going to plug it in. Where VoltServer fits and where we provide the most value for our customers is providing that power layer in a cost-effective, efficient manner for critical power. And that could be anything, you know, we're seeing now that it could be heat pumps, it could be IT switches, it could be cellular DAS radios, it could be a host of different applications that frankly we my team and I aren't even aware of yet. That's the benefit of a venue like this, or a forum like this, I should say. One of the things that I want to stress, and I wanted to close with, so I appreciate having an opportunity to speak here, Patrick, is call us. We'll tell you if we're a good fit or we're not. We don't want to waste your time. Like I said, we want to be consultative, and we want to help you get to the right solution. Because if we're not the right solution day one, guess what? If we treat you right and we're honest and forthright with you, a year from now, when we are the right solution, you're going to pick up the phone and call us back and say, hey, I've got something that you're a good fit for. I can't tell you how many times that's happened since I've been here. So,
Ken, thank you very much. The apathy and the plug in the wall is going to stick with me, and I suspect it'll resonate with much of the audience that is still here. We thank them very much for sticking with us past an hour. At Cabling Installation and Maintenance, our thanks go to VoltServer for sponsoring this session, making it possible and making it happen through the expertise of Stephen Eves, Stan Milnick, Ken Heidzik, and Rona Davis today. Of course, we thank the members of our audience for joining us. We thank you for the questions that you submitted. And as I mentioned a few minutes ago, we know that we're leaving many on the table here today, but please know that these questions are being captured, are being retained, and it's possible that you may be hearing some follow-up offline. Sorry we didn't get to everything today, but we really sincerely appreciate the interest. The list of unanswered questions tells us that interest is great. There's a lot to learn, a lot to know, and a lot to move forward with on the fault managed power front. So we thank everybody for joining us once again, and we wish you all a great rest of your day. Thank you.